Hi, this is ZebraCode.io, and we are on Lesson 11. And we're learning about the game of Nim. You should have looked at the assignment so you understand the rules of the game. And now we're going to start writing some code or just put together some ideas of how we get started of writing this code by looking at some possible functions here. So we might look at, for example, a function, something like is game over. And this would take an input of the number of sticks that are currently left. And then if would return either true or false. So what we're trying to do is to take this game, and the nice thing is you get to be the architect and get to design how all the components are going to fit together, and we're just exploring different ideas now here with those ideas. And then we'll put together a little bit of code to see if the ideas make sense. Another one might be a function. We might put together a function that says take CPU turn. So when it's the computer's turn, we want the computer to take a turn and return back something. So we look at the inputs and the output. The inputs might be the number of sticks that are currently left at the beginning of the turn, and then, for example, we might return how many sticks are left. I'll just call it SL, capital SL, representing sticks left after the turns. Similarly, we might have another function called take person turn, and same idea. We'll input the number of sticks that are currently left before the turn, and then we'll return the number of sticks after the turn. So we're building these functions. These are small parts of the program, and we are going to design them and call them out of our main program. So let's start to put this together. So how might we then put all this together? And again, we can have many other functions. We probably should have a function that tests whether a turn was valid, or you might want to have a function that toggles between the human and the person and the CPU's turn. But let's go ahead and just write some code with these few ideas that we can do. Let's import random. We're obviously going to need random because the computer is going to have to at least initially do a random to determine its turn. So we can do def is game over, and we're going to start. The input's going to be the number of sticks that are left. And now if sticks are left are less than 0, well, then we could return true. So the game is over because we have less than or equal to 0 number of sticks left. And otherwise, we're going to return false. So if there are more than 0 sticks left, then we want to continue on because the game is not over yet. So let's do another function. Def take CPU turn, and we're going to have the sticks left is going to be the input parameter, and that's going to be the number of sticks that are at the start of the turn. So now we can use our random functions. X is assigned the value of random.randint, and we're going to put in parentheses the two outer bounds, 1 and 3. So this is going to pick a number including the endpoints 1 and 3, between 1 and 3, and that's going to be assigned X, and that could be the computer's turn. So the number of sticks after the computer takes its turn could be defined as remaining is assigned the value of sticks left minus X. Now, as we get closer to the end of the game, we want the computer to be a little bit smarter and make sure it makes a valid move. But this is a good start just to see if we can get the bare bones skeleton of the program working as we expect. Next, let's start the logic for the person's turn, and we can create a new function called def take person turn. And similarly, it's going to have an input of sticks left, and what it's going to return is the number of sticks remaining after the person takes its turn. Now, the person takes its turn, we're going to have an input statement. We can do X is assigned the value of input, and we'll prompt the user to enter the number of sticks that the person wants to take. And we'll probably want to eventually put some logic in here to make sure that they're making a legal turn. For now, we can just prompt the user that you have to take something between 1 and 3. So this will tell the user that it's his or her turn and what he or she should do, and then return the appropriate value. Again, we can have a variable called remaining, and all we got to do is assign the value of sticks left minus X, and that would return it here in this return line. Next, let's work on the skeleton of our main program, and we will try to call some of these functions that we've just created and see if we can build a bare bones skeleton of what our program might look like. And we can start off with sticks is assigned the value of 18 because that's when the program starts, is we start with 18 sticks. Now we have a while is game over, sticks is equivalent to false. So this is going to be our main loop. The game is going to continue until is game over is set to true. And so this is basically our main loop, and we can toggle between the computer taking its first turn and the person taking the first turn, and we can then have kind of a framework of how everything's going to work together. Let's start by having the computer go first. Now, when we get to our final program, we probably want to have a random generator that determines whether the person or the computer goes first. But let's start simple and let's create a variable called sticks and assign the value of take CPU turn. And it's going to pass the current number of sticks in, and the output is going to be, or the return value is going to be the number of sticks after the CPU has taken its turns. So let's see what the computer did. We can do print CPU took turn. That's just a statement of whose turn it was and what just happened, essentially. And we can now have string sticks, take the value that's returned, which is the number of sticks that are left, and we can concatenate that with the number with a string called r remaining. So it will tell us how many sticks are remaining after the computer took its turn. Now, we'd probably want to have a toggle here. We go back between the computer and the person. But what if we just try to run this program and see where we are if the computer just took many, many turns over and over again, and see if we can start understanding the framework. Let's run this program, Python nim.py, and we can see we started with 18, and then we have 16, so the computer must have took 2, and then from 16 to 15, the computer must have took 1, and we go all the way until we get to, we have less than or equal to 0, and that's when the game is over. So this is a bare bones framework of the computer just taking its turn until the game's over, and we need to build a lot more functions to verify that the turn was accurate, and to verify it, or to have a toggle between the computer and the person, and to print out to the screen exactly what's happening with each step of the way. But hopefully you understand how this game might fit together, and once we understand this, how we might build a more complex program when we're playing NIM with 3 piles. Thank you. This is zebracode.io.